The topic of discussion is basic set theory. We will use Venn diagrams in this case. Let's assume that we have this region omega, this set omega. This is the closure of omega, which is the union of omega and its boundary points. This theta omega is denoted by the boundary of omega. Now let's say that we have the following statement: x belongs in set omega 1. Let's say omega is a subset of Rn, of the n-dimensional Euclidean space. And x also belongs to omega 2. How can we represent that? So we have two bounded sets, omega 1 and omega 2. So we shade all the areas here. Now let's say that x belongs to omega 1, but x does not belong to omega 2. It's this case here. This is omega 1, this is omega 2. It belongs to omega 1 but doesn't belong to omega 2. So we sketch this this part here. This is omega 1, this is omega 2. This is their intersection. But x only belongs to omega 1 but doesn't belong to omega 2. So let's say that these two overlap. We keep only this part in omega 1. X doesn't belong in omega 1, but x belongs to omega 2. So it's omega 1 and omega 2. I want these values here. Only these values in omega 2, but I don't want the values in omega 1. This set can be written as in the following way: omega 1, take away the intersection part of omega 1 intersection omega 2. And this is omega 2, take away the intersection part omega 1 intersection omega 2. Now x doesn't belong in omega 1 and x does not belong in omega 2. This is omega 1 and this is omega 2. And let's say that they are subsets of omega. So it x doesn't belong to any of these sets, so we highlight this region here. We have also the case that U1 intersection U2 is an empty set, which means the following: that omega 1 and omega 2 do not intersect. This is omega 1, this is omega 2. So this intersection here is empty. Is an empty set. Now let's see De Morgan's laws. You have omega 1 union omega 2 complementary equals omega 1 complementary union omega 2 complementary. You have omega 1 intersection omega 2 complementary, and this is omega 1 complementary intersection omega 2 complementary. So let's say that x does not belong in omega 1 and x does not belong in omega 2. This means that x belongs to omega 1 complementary and x belongs to omega 2 complementary. X doesn't belong to omega 1 union omega 2. So from here we know that x belongs to the omega 1 union omega 2 complementary. If we merge these arguments together, we finally get that omega 1 union omega 2 complementary equals omega 1 complementary union omega 2 complementary. The other law, so this is the first Morgan law. The other is omega 1 intersection omega 2 complementary equals omega 1 complementary intersection omega 2 complementary. X doesn't belong in omega 1, so x belongs in omega 1 complementary, and x does not belong in omega 2. X belongs to omega 2 complementary. X doesn't belong in omega 1 intersection omega 2, so x belongs in omega 1 intersection omega 2 complementary. So from here what I get is omega 1 intersection omega 2 complementary equals omega 1 complementary intersection omega 2 complementary.